I'm Youyou Cong from Science Tokyo. I would like to share with you my ideas on creating an educational fragment of Scala. So the motivation of this work comes from an introductory functional programming course that I am teaching in my institution. The course teaches how to systematically design programs based on the Felice et al.'s program design recipe. And it is attended by second-year undergraduate students majoring in computer science. And as a functional programming course, it covers topics such as algebraic data types, and recursion, and higher-order functions. So this course has long been taught using Scala because Scala is functional and it's close to Java, which is used in a later course taught in my department. I think Scala is a cool language, but after teaching this course for like 6 years, I realized that the full Scala language is probably not ideal for my course. And there are mainly 3 reasons. The first reason is that Scala often produces error messages that my students don't understand. So suppose a student wanted to compare a function argument with a number, but they used a single equal operator instead of the double equal operator. In this case, Scala will complain that reassignment to val is not possible, but this doesn't make a lot of sense to my students because they are not familiar with the notion of assignments. Yeah, and the second reason is that the semantics of some operations and the appearance of values can be confusing to novice programmers. For example, in Scala, we can concatenate a string with a number without converting the number into a string. And this kind of heterogeneous addition could be surprising to my students. And also, the resulting string is displayed without being surrounded by quotation marks. And that is inconsistent with my students' knowledge that strings are always surrounded by quotes. And the third reason is that Scala often exposes the what's happening? Okay, so Scala often exposes the object-oriented side of the language, even if we are programming in the functional fragment. For instance, higher order functions like map are a functional feature, but they use the object-oriented style dot notation. And this makes it a little bit challenging for me to explain, for instance, how many arguments the map function receives. So there are some inconveniences with full Scala. And in fact, these inconveniences are not unique to Scala. It has been claimed that no full-blown general-purpose programming language is particularly appropriate for introductory education. And this is why people have developed educational languages like Pirate and educational fragments of an existing language, such as the teaching languages in Dr. Racket. And inspired by these languages, I would like to create an educational fragment of Scala following these 3 design principles. First, the language has to have a restricted syntax, and it produces error messages based on that restricted syntax. And second, it evaluates and displays expressions in an easy-to-explain way. And third, it includes features from only one programming paradigm. Of course, there may be multiple versions of educational Scala suited for different kind of courses. And in the rest of this talk, I will sketch the design ideas for a version that will work well for my course, which is about functional programming and is attended by students with little or no programming knowledge. So let's start by looking at some of the constructs that I would include in my version of educational Scala. Variables are all immutable, and function definitions must have a body, and similarly, conditionals must have an else branch. For algebraic data types, I require all constructors to be fully applied because my students often forget to supply arguments. And for higher order functions, I would design their syntax so that they explicitly receive a list as an argument, just like in OCaml. And next, let's compare the error messages produced by full and educational Scala. So this is the same program that we saw before that performs comparison using a single equal operator. In full Scala, this is interpreted as an assignment, but in educational Scala, we don't have this notion of assignment, so we can guess the intention of the programmer and directly suggest the use of the double equal operator. And here's a different example. This function definition lacks an equal sign after the output type. In full Scala, this is interpreted as a declaration of an abstract method, but in educational Scala, there's no notion of method, and we require a function definitions to always have a body, so we can again point out the error in a direct way. And here's another example. So we are defining a shape data type that has a square constructor taking in a length as an argument. And then we are creating an instance of a square, but we forgot to supply arguments. In full Scala, this results in no error at all. But in educational Scala, we require every constructor to be fully applied, so we can remind the programmer to supply an argument. So these are some of my preliminary ideas for educational Scala, and there are many open questions that I would like to discuss with you. First, I believe that some of you have experience teaching Scala, and I would like to know what are some common challenges faced by Scala beginners. And I also believe that many of you are familiar with the implementation of Scala, and I would like to get some advice on how to implement such educational Scala. As I mentioned, there may be different versions of educational Scala, so it would be nice if we can make the language easy to customize by teachers, but I don't know how to do that. And although I'm proposing educational Scala for classroom use, it might be useful for like industry training as well. And in that case, would we design the language in a different way? And lastly, we might be able to address some of the beginner challenges without creating a new fragment, and I'm also open to that direction. So if you have any thoughts on these questions, or if you're interested in collaborating on this, please speak up or talk to me later. Thank you.
Thank you. So any questions?
Hello, thanks for the talk. I think one of the things that immediately popped into my mind is I think a lot of the examples that you demonstrated in the talk is something that I would call kind of like an actionable error message, right? Things like, so in your first example, we have this x equals 0, and the compiler was able to guess that maybe the intention was to do a comparison instead of an assignment. And this is kind of something that, for example, the Rust compiler is fairly known to have, that every kind of error messages that it produce has some kind of actionable thing. Like maybe you can try adding an ampersand, maybe you can try changing this, changing that. And I wonder if it's something that, that you would want to have.
Okay, thanks for the question. So yeah, my proposal is kind of like actionable error messages, but I'm borrowing the ideas from the teaching languages in Dr. Rocket. So they restrict the language to a beginner subset so that they can precisely report the errors. So maybe, so I don't know how Rust compiler works in terms of error messages, but yeah, probably we can just produce a bit better error messages without really creating a new restricted fragment. That's probably possible, yes.
Thank you.
Thank you for your talk. I know many people don't like AI, but I do think that you can make use of LLM to generate more friendly, beginner-friendly error messages. Like the example, like you can provide and error, and maybe most of them generate good error messages. Thank you.
Thank you for the suggestion. Yeah, I think that's possible.
Hi, I was curious if you might, whether there is interest in examining the theoretical foundation of like how students pick up and then use the language incorrectly. So like psychological in the psychology sort of field to sort of mix it with the semantics of the educational Scala. I'm not very familiar with this, so I was just curious. It's like you treat it almost like a linguistics problem, you know.
Thank you for the idea. I haven't thought about like doing a theoretical like foundation for this project, but that might also help us design a good language. Yes.
Hi. This is not really a question, but a suggestion or an opinion as a student. I'm still an undergraduate, and similar to your students, I am learning Scala as a beginner. Although I've worked with FP before, so I do get the nuances that you have mentioned in the slide and why the Scala compiler behaves it does currently. And I would personally suggest not to fragment Scala to have an educational language. This might be a bit very controversial or very opinionated because this encourages behavior from students to not go and learn the tool they're using and the semantics behind it. And yes, it would make it easier for students to rewrite their functions when it approaches errors. It does not teach them the underlying reason the compiler has those semantics in the first place. Perhaps you could see what Rust did a better example is the Rust book, which is called The Book, has an open source forked book by Brown University called the Rust Lang. And the person who actually created this book took inspiration from the philosophy behind HCI, human-computer interaction, and what is the general way users want to use a particular interface, the Scala, the standard library API, and how students would view it. They go through this in the book and quiz you and visualize it better to teach you things like ownership and borrow. Similarly, I would suggest instead of creating a new fragment or a DSL on top of Scala or some other educational Scala special fragment of it, I would suggest a more concise book where you can probably go through the operations and types of Scala and quiz the students. That would teach them more about Scala tools than hiding than just forcing users to have extra compiler messages or error messages that tell you, oh, maybe you're missing something over here. For example, the assignment operation versus the equality check. That's more of a syntax error, and if students don't understand the reason behind the difference between the two syntaxes, use of equality, they will not be able to progress beyond the Scala development. They won't become language agnostic. They'll be stuck. They won't understand theory more than the language itself. So that's just my suggestion. Thank you.
Okay, thank you.
I understand both points. So regarding your third question, I don't know if you know Hedy, H-E-D-Y. It's a programming language where you can unlock new features.
Hedy.
Yeah.
Yes.
So that's an approach where you could add new language constructs to the parser, and it would enable new languages. I'm also not sure about the fragment, and I had a couple of other reasons. So I teach a similar course. We use Haskell. I'm not very fond of the laziness for that purpose, but if you open any Haskell function, second-year students can read them, right? So now, would your educational Scala functions be implemented in educational Scala itself or in regular Scala? Because it's useful for students to open the definition and be able to read them.
Yeah.
So that's a little bit tricky. Then things like losing the dot syntax for the methods, you lose the autocomplete, and by having the fragment, if they go into Stack Overflow or ChatGPT or whatever they use, they also lose this whole corpus because they're limited to a subset, which is what Hedy does on purpose. So I don't know what's the best trade-off, but I think these are all things to consider, I would say.
Thank you.
Thanks for the talk. So, are you planning to have documentation for the language? Are you planning to have some form of documentation for language? And also, would that be based on the would that be like a slice of the current Scala documentation?
I don't have a concrete idea, but I just want something that I can use in my class. Yes.
Thank you for the talk. I want to echo the other opinions to say you would have, we can have together much more impact to improve the error messages of Scala, of the Scala compiler in general than to define an educational fragment. On the other hand, it's much harder because by defining an educational fragment, I can rule out certain things like an abstract method, for instance. So, or I can say, well, I don't have assignments, so every equals must be a test, and the user forgot to write equals. But in a lot of these cases, I think the compiler can figure these things out. So for instance, the val x equals 0, that should be possible, right? So if this is in a condition of an if or somewhere where an expression is expected rather than a statement, the compiler should figure out that probably that's what it's meant. But it requires a lot of engineering. So I want to sort of have a call to action. I think this is very important, good error messages. We should do put a lot make a lot of effort into it, but it's the question is what can everyone do? So have tooling and compiler sprees every 3 weeks. Mathieu is organizing them, so approach him. We essentially pair people with people who know the compiler, and so you can learn about the internals and work on that. If you feel that hacking a compiler is not your thing, then I believe it still would be super valuable to have a well thought out issue. So we have an issue tracker in Scala 3 to write an issue to say this is a confusing error message. I think under this and this condition the compiler could give a much better error message. With that other people can act on it. But I think a lot of value, what you did in your talk is essentially distill things to say, well, this is confusing, and once you, even if you say this is confusing, then this is already very good. If you say this is confusing because I believe that the compiler should be able to figure it out, that would be super valuable. So not just, so thanks for the talk, and everybody call to action. It would really help a lot if people would start doing that. Thank you.
Thank you.
So thank you for the talk. Let's give her another round of applause.